All right, we've got 4 new rules we are learning for 3.5b. So I'm just going to show them to you. And if you're in class this day, we actually did showed how or where they all came from. But I'm just going to go ahead and just show you what the actual derivative of each of these are. So the derivative of the tangent, so if I'm going to take the derivative with respect to x, then the derivative is secant squared x. Another way that you can write secant squared x is by squaring the entire trig function. What you cannot do is write it this way. So we do not want to write secant squared x or quantity secant x squared this way. So we don't want to do that. Nope. Okay, so just to keep that clear. The next one for cotangent, so the derivative with respect to x of cotangent is negative cosecant squared x or negative cosecant x all squared. For secant, the derivative is secant x tangent x. Don't forget that first x right there. And for cosecant, that one is negative cosecant x cotangent x. One trend that you might have already picked up on is if you're taking the derivative of a trig function that starts with the letter c, you will have a negative result. All right, for example 2, like in your packet, example 1 was just finding all of the derivatives using sine and cosine for those 4 trig functions. But for example 2, if I want to find the derivative here, I'm just going to go through, let's see, f prime of x. This is a constant times the trig function tangent x. So this is going to be 3 times, and the derivative of tangent is secant squared x. So I'm just going to write secant squared x. And then minus 2 times the derivative of cosecant x, and the derivative of cosecant x is negative cosecant x cotangent x. So I'm going to then change this negative here to a positive, and that's it on that one. Okay, now for this one here, notice that I have 2 functions being multiplied together, so I would have to use product rule. But one thing that you can always do, if you notice that you can simplify a function first before taking the derivative, that really does help. So I'm just going to show you, I'm not going to show you all this work, but if you end up doing product rule and having to simplify your answer, there's all of this work involved up to here, right? Up to here. But if you actually simplify this function first, it'll actually just take up that much space, which is a lot easier. So I'm going to show you how you can simplify this first. If you see that you can transform these trig functions into sines and cosines and see that you can get some of the factors to cancel away, then that will work. So for instance here, cotangent is the same thing as cosine x over sine x, right? Because tangent is sine over cosine and cotangent is the reciprocal of that. And secant x is this reciprocal function for cosine. So secant x can be written as 1 over the cosine of x. So we can see here, I can actually reduce this function by crossing out the cosines and then rewrite this as 1 over the sine of x. Now, even if I leave it like this, I would have to do quotient rule. However, if I recognize that 1 over sine x is the same thing as cosecant x, all right, because cosecant is the reciprocal to the sine function. So I just simplified my g of x function, and now I'm just going to go straight to finding the derivative of cosecant, which is on our list, and that's the negative cosecant x cotangent x. So if you last year when you did all of those trig identities and you had to simplify and make, both sides of the equal sign the same, and those are kind of challenging. If you're good at that, you're going to do well here, or it's not going to be as challenging. But if you struggled with that, it might take you a little bit more work because you might not see ahead of time that you can manipulate the function or simplify it to make the derivative process easier. But either way, you can still end up with the same answer.